Good morning, everyone. This is Joanna Mbarak. I'm the head of Patek Labs. I'll be presenting on Darknet HoneyBots. This work is in collaboration with Laris, Lebanese University. I will start by introducing the problematic, then I will define our first naive bot. Next, I will be presenting the advanced HoneyBot and describe our contributions. At the end, I will conclude and present our future work. The first section will illustrate the TOR network. The web, in general, is composed of two parts, the surface web and the deep web. Surface web, also known as ClearNet, makes about 4% of the World Wide Web. All its content is easily accessible to anyone. On the other hand, the deep web, the subset that is not searchable, consists about 96% of the total World Wide Web. Its content is not accessed or indexed by any standard search engine. Academic databases, medical record, financial record exist somewhere in the cloud but are not searchable on search engines. However, the dark web is a subset of the deep web. It is the anonymous part of the deep web that you can only get access to through overlay networks. To access the dark web, an anonymity software such as TOR should be used. The darknet is the hidden part of the web on which a large traffic of illegal activities and services is organized. The TOR network is probably the best known part of the darknet. It gets its name from the way the data is encrypted, stacking the encryption layer like onion peels. This data is then sent according to a circuit made of nodes that are randomly selected. Each node can only decipher its peel of the onion and only knows the IP address of the previous and next node. TOR provides anonymity, masking users' connection. Hence, the risk of finding the origin of request is practically impossible. In a previous work, we have implemented and monitored two different kinds of honeypots in the dark web. The first honeypot consisted of a research honeypot, which is said to gather intelligence on activities of cybercriminals and to monitor a well-secured chat room and closed forum. On the other hand, the second honeypot was a production honeypot set to detect attacks and to know who is looking for hacking services while knowing their purpose. Major requests dealt with pornography and hacking solicitation. Also, some remarkable posts included HTML injection, mega account, and file shared, ethical hacking links, pornography, random links, onion mail service provider, etc. This work constitutes an extension to the research chat room honeypot, making it more active with faster replies and relying on deep learning techniques. Deep learning itself is an approach to machine learning, and it uses what is recognized as neural network. This section will illustrate the first naive darknet honeypot. We will understand the two phases of our research, the usage of encoder and decoder, and the operational step of LSTM. Our findings reveal the shortcoming of the naive honeypot when applied to darknet chat room honeypots. Our first naive darknet bot was based on Cornell movie dialogues. After importing the Cornell movie dataset and cleaning the question and the answers patterns, the data pre-processing included tokenization and creating word-to-end dictionary. The phase 2 consisted of building a sequence-to-sequence model. Sequence-to-sequence is a type of encoder-decoder using RNN, recurring neural network, It can be used as a model for machine interaction and machine translation. These structures, built to process sequential data, are the basis of great advances in NLP, whether for language modeling, translation, or automatic text summary. The model includes an encoder and a decoder having words or items as input and giving different sequences as output. The encoder receives an input sequence in the form of a hidden state vector and forwards it to the decoder that generates the sequence of the output. LSTM is a type of RNN widely used in NLP. The idea behind this choice of neural network architecture is to provide the signal between what is important in the short term through the hidden state and what is in the long term through the cell state. The overall operation of an LSTM can be summed up in 3 steps. 1. Detect relevant information from the past drawn from the cell state through the forget gate. Choose from the current input those that will be relevant in the long term via the input gate. This will be added to the cell state, which act as long memory. 3. Pick up important short-term information from the new cell state to generate the next hidden state through the output gate. Like the RNN, the LSTM therefore defines a recurrence relation, but uses an additional variable which is the cell state. In this model, the last output strongly relies on the context defined by the hidden state in the final output of the encoder. Furthermore, dealing with long sentences is a challenge, given that the context may be lost at the end of the sequence. Finally, the model is characterized with inputs for the encoder and the decoder and the output target sequence. We can now compile the model using Adam optimization function and categorical cross entropy loss function. The model is fit with a validation split values equal to 0.2, which means that 80% of the dataset will be used for training. The model weights are saved in a file, and once the designed model is fit, it can be used for prediction. In other terms, given a message, it should output an appropriate reply. As for the results are not convincing and not adapted to a chat from HoneyBot. The replies were not appropriate as response to the question, and the messages were not adequate and out of topic. Therefore, the model and dataset were changed. This section describes the advanced HoneyBot by dataset, data preprocessing, model building, model training, and testing. Datasets were selected inspecting the data being in English and taking from Darknet forums, more precisely Silk Road and Wall Street. Both operated as TOR hidden service on the dark web. User requests are anonymous and secure. Silk Road was the first online black market, mostly known as a rostrum for selling illegal drugs, and considered before its closure as the largest online store in the world. Closed in October 2013, the site also offered hacking kits, forged paper, and hired killer services. As for the Wall Street market was formerly the world's second largest darknet trading platform, specialized in the sale of illegal goods and false documents. The platform had more than 1 million user accounts, thousands of suppliers, and items available for purchase. So before beginning to train, data preprocessing must be performed. This means that the text entered should be understandable and the most readable possible. For that purpose, we defined a function to clean the text and simplify the data, removing characters. A manual cleaning was done as well to remove the names of dealer and customers, independent discussion or monologue, and the long messages on offers. Data structuring is depicted in Table 1. Furthermore, code structuring was performed to prepare the data set for the training by tagging and splitting the data, as per the Table 2. Additionally, 2 text files were created containing the messages and replies respectively. After cleaning the strings, it's time to transform these sentences into integer coded words. An encoder decoder was used for that purpose. This class had the vocabulary that contains all the words that have occurred in any message or reply, in addition to 3 functions: the constructor, encode function, and decode. The constructor is for initializing the class and putting the words into the vocabulary. The encoder function encodes the message into a bag of words, and the decoder does the opposite work of the encoder. The transformer model was introduced by Google in the paper Attention is All You Need. It's a model that uses the attention mechanism, allowing the decoder to pay attention to the different part of the input sequence and not to the sequence as a whole. The model learns how to generate a context vector for each output. This model uses a multi-head attention layer consisting of multiple scale dot product attention that has 3 inputs: the query, the key, and the value. The normalization is applied to the key, and the output is the multiplication of the attention weight with the value. This decides the importance we give to the query so that the words of importance are kept and irrelevant words are eliminated. The model was trained using the following parameters. A for loop was created to iterate through each epoch and train the model. Messages from the dataset that have no replies were used to test the model. As for the testing result, the result convinced us having good answer to input with this model adapted to the Darknet chat room. Grid search cross-validation method can also be used. This work focused on chatbot design techniques in order to create an advanced honeybot designed specifically to deal with Darknet activities. Sequence-to-sequence and transformer are both models that generate an output sequence when given an input sequence. As we have seen, sequence-to-sequence relies on recurrent neural network and LSTM layer, which with our sequence lengths might have set them up to fail. The transformer model, on the other hand, uses much more complex layers, notably multi-head attention and positional encoding, that have a mathematical foundation which make it prone to parallelization and enables our model to keep up with the sequence on a large scale without being impacted by its length. To conclude, the new honeypot aims to collect evidence and valuable information regarding Darknet malicious activities. Further investigation using the implemented Darknet chat room may lead to new indication of malicious movement. Any question? Thank you.